Hi guys, can we get the village rename?
All right, Carl, are you ready to start? Could you unmute yourself and say yes?
Yes, sorry.
Cool. Welcome everyone to the award ceremony for the Berkeley Math Tournament. Actually, I should. We are very excited to welcome everyone to this award ceremony, and we are excited to have all of you guys here attending and all of you guys streaming the YouTube video online. And yeah, so I just wanted to give a little bit of a statement overall. First, I want to congratulate everyone for coming here and doing this like virtual tournament and participating in this like experiment with all of us. This is the first time we've experimented with something like this. We've had some guidance from a couple of people, but ultimately this is just something that we wanted to try out given our history, and we just wanted to figure out can we do something like this online. And we're thrilled with the amount of participation we got. We've had record numbers of people, so thank you for everyone who's on the West Coast, on the East Coast, in Toronto, overseas, everyone who's here. Thank you for coming. And yeah, this award ceremony is essentially sort of by nature of being an award ceremony, it's essentially like congratulating the winners. But I want to talk about basically everyone for a little bit. I think I want to express support that like, hey, like math competitions aren't just about winning. They're about meeting new people, engaging with math. That's really, really interesting, and sort of seeing the underlying beauty of some of the problems from different areas. We had some new events this year that explored those type of areas. We did a video contest for the first time this semester. We had activities that were focused on more estimation-esque things and more higher level mathematics. We really want to emphasize that math tournaments aren't just about competing, but it's also just about engaging with mathematics. And we hope that you guys take some of our problems and come to your next math competition, be like, hey, these are really interesting. Let's try and figure out what the tricks are to these. Like, just because you didn't finish it in an hour doesn't mean you're not going to be able to finish it in the future. So I just want to say good job, and thank you for participating to everyone out here, and for all of you future mathletes who could go into careers in STEM, in pure mathematics, in computer science. We're really rooting for you and for the future of our education system to be rooted in logic and mathematics. All right, thank you guys so much, and let's move on to the next slide now. I want to give a big thanks to all of our volunteers. This would have not been possible without the help, especially yesterday's event would not have been possible without the help of all of these people listed below. Mark, Sylvia, Aditi, Gilbert, Jihi, Noah, Jamie, Titus, Ananya, Ellen, Samuel, Sarah, Destiny, Rebecca, Ilyun, Simran, Arman, Alex, and Emily. Thank you so much for spending the time proctoring and debugging and making the tournament a very, very successful event yesterday. And big thanks to Aditi in particular for staying back and doing a lot of the data science work with us. She really, really helped, came through and helped us out. Yeah, let's move to the next slide. Yeah, let's. I want to give the floor to Darren. One of the things about math tournaments that I really love is the potential to have community outreach. So here is Darren ready to talk about nanomath for, yeah. So Darren, do you want to take the stage?
Yeah. Am I on the stream now?
Yeah.
All right. Hi, everyone. So my name is Darren. I competed in the Berkeley Math Tournament this weekend. And actually, one thing that I'm doing is I also run the math organization called Nanomath. And we run events. So we do math competitions. So the first one is the Fall Math Meet, which is next week on Saturday. And in the future, we might do additional contests and then like Ask Me Anythings with professional mathematicians or people who have been successful in contests or anyone else, and then guest lectures and some other events. All right, next slide, please. So here are some of the people who have been involved in the NanoMath team who have helped make this competition possible. All right, so here are the details for our competition. So it's going to be next Saturday. It's a live competition over Zoom. So basically everyone will be in one Zoom room. And then it starts at 9:15 a.m. Pacific time, but there will be check-in beforehand. So check-in will be to resolve any team issues or figure anything out that you need to do before the round start. So we're going to have a team round, which is not gut style, but instead it's 15 questions for a team of 3 people to solve in 1 hour. So this contest is taken in teams of 3. And then the individual round is pretty similar to the ARML format. So there are 5 pairs of questions, and for each pair of questions, you will have 10 minutes. And then there's also a speed round where you have 50 questions to solve as a team in 30 minutes. So the difficulty of this competition is between, so beginner means basically anyone who is doing well in their high school math class can meaningfully participate. And then the upper end of the difficulty level is roughly late Amy. And then we're also going to have an estimathon. So I assume that's pretty similar to the estimathon at this competition. Simon will be giving a guest lecture on tiling rectangles. And then Professor Po-Shun Lo from Carnegie Mellon and XB will be doing a problem review. So here are the links for registration and to join our Discord server for announcements and updates. Thank you, everyone.
Yeah. Carl, is this the right? Yeah. So we just wanted to announce the video contest finalists. Our first finalist is the UTSE team from University of Toronto Schools. And our second finalist is not second place from Thomas Jefferson, it looks like, or THJHSS. Yeah. And now we're going to announce the winners and actually play the videos for you guys live because we thought they were really fantastic. So yeah, first winner, Orange Mustang from Homestead High School. Carl, I don't actually hear anything. Can you share your computer audio?
Yeah. Let's see if this works. Sorry.
One day you trip over a rock while carrying
Can
a
you hear
part of
that?
your church's stained
Yeah.
glass mosaic. A part of this.
Oh, there we go. Sorry.
One day you trip over a rock while carrying a part of your church's stained glass mosaic. A part of the stained glass mosaic breaks off and shatters. You need to find the length his size lengths. However, the length of the side is faded, so you can't tell what it was. How can you find the length of the final side of the fragment? You have no measuring tools, but you have measurements of all the other fragment sides. If the pastor finds out, you will be excommunicated. What could you do? You faintly remember that time in Homestead Math Club where the officers were teaching a theorem about the proportionality between sides of a triangle. If only you could remember.
Say that we have triangle ABC and we draw a line from each vertex to the opposite side and have each of those lines intersect at one point. Let's label the middle intersection point P and the intersections with each of the sides D, E, and F. Now let's take a look at specifically triangle CPE with height H. We can write the area for this triangle as 1/2 BH, which is the same as 1/2 CE times H. Now let's take a look at triangle BPE, also with height H. The triangle will also have its area as 1/2 BH, but instead of B, the base is EB. This gives us the equation for the area of the triangle as 1/2 EBH. Now that we have both of these equations, we can make a ratio between them and get that the area of CPE over BPE is equal to 1/2 CEH over 1/2 EBH. We can further simplify this ratio by canceling the 1/2s and the h's. Get that CPE over BPE is equal to CE over EB. Increase the length of H and take a look at triangle CAE with the area 1/2 BH, which is 1/2 CEH. Also the triangle BAE, which has an area of 1/2 BH, which is 1/2 EBH. If we make a ratio between the areas of the triangles CAE and BAE, the 1/2s and heights can be canceled out. And what's left is the ratio between the two triangles to the two bases. Triangle CAE over BAE is equal to CE over EB.
We now have two area ratios with two sets of triangles. However, triangle CAE contains two smaller triangles, CPA and CPE. The sum of the two areas of CPA and CPE gives us the area of CAE. So the difference between the areas of CAE and CPE results in the area of CPA. Using the ratios we had earlier, we can multiply the area BAE to CE over EB, which isolates CAE. And we can also multiply the area BPE to CE over EB, which isolates CPE. Since we isolated CAE and CPE, they can be substituted into the equation involving the sum of the triangles as shown. The ratio CE over EB is factored out, and when the area of BPE is subtracted from the area of the triangle BAE, the resulting triangle BPA is formed. BPA can be substituted for the difference in the two areas BAE and BPE in the sum equation, and then multiplied on both sides to get the resulting equation, areas CPA and BPA equal to lengths CE over EB. We can apply this property for every other side as a base. You get these three ratios, and you can see that if you multiply all of the triangle area ratios together, it all cancels out and it equals 1. If we substitute all of the triangle area ratios with the base ratios, then you get Seva's theorem. You can further simplify this and see that the product of every other part of a side is equal to the product of the latter sides.
You can see from the stained glass triangle that it is formatted just like the triangle from Math Club. Just plug in the values of all the sides you have and then isolate your unknown side. Then you have your answer.
That was a fantastic video. That was a very clear explanation of Seva's theorem. That's why it was the winner. And now we're going to play one of the best math raps I've ever heard in my life. Go ahead.
Oh no, backwards.
Welcome to projective geometry, where certain figures in high dimensions can be projected down onto low and lower dimensions. Now don't go fall asleep underneath your full attention. Imagine you were standing in a room looking up at the ceiling. That's right, you know what's up. If you move your head, you will be able to see every point on the ceiling that there can be. Now imagine the ceiling was infinitely large. With 20/20 vision, you could see really far. You would have a clear line of sight on every point of the ceiling. You feel me now? Abstracted by. You're standing now with your head down at the origin of R3. That's 3D. You've got 3D lines of vision. Those vision lines all originate at the origin, while the ceiling is C equals 1 in the orange ink. Every point on the plane C equal to 1 has a unique line of vision, origin begun. Well, line of vision from the origin close to none projects on a point unique on the plane above. Since each line for the origin is half above, half below, this half space above equals the half space below. It's like the ceiling above you and floor down low, where there's a mirror that reflects everything down below, yo. But some lines of vision don't match the points in the plane. In your hypothetical room, if you look straight, you won't be looking at points on the ceiling above, nor looking at points on the ground or thereof. So where did the lines lead? Where do the points read? Any line on the plane of C equal to 9 won't cross C equal to 1 at spots on the plot. Now, what could these points possibly represent? Suppose you are watching just one among them, a ceiling that moves away from you. Your line of sight moving lower till the point's out of view. Here in the limit, you are now looking straight. The points represent infinitely far away. In LaTeX lingo, they're at /infiniты. There's one catch, though, that we ought right now to make plain. Since each other line creates a point in the plane, These lines, 2 is 2, make a unique point at infinity. So, in other words, looking straight in one way is the same as checking your 6, okay? Now, this fact may cause you some level of dismay, but fret not, for things work out better, one could say. These points that are on the classical 2D plane combine with points at infinity to form an extended plane, which the mathematicians call real projective plane. We're sincerely sorry for making this rhyme quite lame. Now, points on the projective plane are lines in space. These are prescribed uniquely by their direction. Use a vector ABC to put them in place, scale up and down, get all points without rejection. Now, what point is ABC on the plane, you plead? To scale it to z equals 1, and you will see that the point goes to A by C and B by C, while C, when not, is a point of infinity. Next question, what becomes of a line in R3? A line has many points, don't need a PhD to find a span of lines that lie flat in 3D. It will just end up becoming a plane, you see? Now, what will this thing even look like? Well, you're going to see. It's a simple relation. The plane for line ax plus by plus c equals naught is ax plus by plus cz equals 0, as thought. Z equals 0 is a plane seeing points far away. It's the collection of points at infinity, hence forming a line in infinite vicinity. Let's move on to the concept of duality. Now, here's an interesting proposition. There's a duality that holds in the third dimension. For every plane that rests upon the origin has a unique normal line with the same beginning. When ax plus by plus cz is not, the normal vector can be confirmed by the dot to be just the direction ABC, which ought on the projected plane hit a unique spot. Every line ax plus by plus c equals 0 has a dual point, a over c, b over c, no? Properties that become reflected as you go. A point through line's dual is the line of dual points is so. Let's say you want to find where two lines come to meet. Gauss-Jordan matrices, time will soon deplete. Instead, consider the line that lies where planes complete. It's normal to both normal directions, quite a feat. Now, how to find this normal of normals, you ask? Well, the cross product comes readily to the task. Arrange your equations in tidy little stacks. The formula is simply Kramer's rule in a mask. Now to 2 points, what line must we designate? Simply find the plane through the lines that correlate. Cross again with 1 as the third coordinate, and well, there's your line, with nothing inordinate. Projections show conic sections in a new light. Imagine the cones project as lines of sight onto our good old plane of z equals 1, as they might. All shapes of conics will get an equal fight. But first, welcome a new player. The unit sphere lines of sight, 2 points of intersection appear. One in upper and one in lower hemisphere. A floor mirror replaces the lower point here. Cones intersect the sphere at circles, quite tame. The cone's equation's difficulty deserves some fame. Instead, cylinders too fit the circular frame from which the circle's equation we may reclaim. One final step we need, homogenization. The equations must be scalable to use projection. Sphere equates sum of squares to unity perfection, multiplying results in the cross-sections equation. And how do these different shapes categorize? For circles, the cones must point up into the skies. Parabolas touch z is not, ellipses capsize, and hyperbola, that's left as an exercise or size. Projective geometry comes up in other places. The projective complex plane is one of those cases. Complex solutions of elliptic curve equation form a deformed torus on every occasion. It's like the solutions of conic sections on a sphere would map to a circle, as here it appears. This gives rise to what we call the genus of a curve, and interesting consequences are therein served. These sorts of curves will come up in cryptography, and to the proof of Fermat's last theorem, they're key. As to algebraic geometry from Italy, but that's for next time. For now, we'll drop the beat. Peace.
Yeah, that beat was fire. Like damn. Anyway, congratulations to Olive. Wait, can you go back to the slide? I don't want to announce the name. Yeah, congratulations to Olive Euler from Mass Academy at WPI. Great job with this video. And then finally, our winner, well, I guess our last winner, BCA from BCA is BCA 1.
100 walks 1 mile south, 1 mile east, then 1 mile north, and ends up in the same place he started. A bear walks by. What color was the bear? This classic riddle actually has 2 solutions, but the more common answer is that the hunter started at the North Pole, went a mile south, turned right and walked east parallel to the equator, then turned north and headed back to the starting point. At first, this seems a little weird that we would be able to do this. Why is that? In classic geometry, one of the first things that we are taught is that the angles of a triangle add up to 180 degrees, no matter what. So if we were to walk one way, turn 90 degrees, walk some more, then turn 90 degrees and walk again, there's no way we can make a triangle and end up where we started. But this isn't classic geometry. This is spherical geometry. Spherical geometry deals with shapes on the surface of a sphere. As for triangles, they definitely don't have to add up to 180 degrees. With the example of the hunter, the triangle had 3 right angles for a total of 270 degrees. So naturally, we have to ask, is there a similar rule for spherical triangles?
First, we have to set some ground rules. What constitutes a line in this non-Euclidean world? Well, on a plane, a line is the shortest possible path between 2 points. So, what is the shortest possible path between 2 points drawn along the surface of a sphere? The answer is that it's known as the Great Circle. The Great Circle isn't actually all that amazing. It's just the largest possible circle that goes through those points. The center of a great circle is always the center of the sphere. The equator, for example, is a great circle on the Earth, but the Tropic of Capricorn is not. Now, we can measure the length between 2 points using the angle they make with the center of the sphere. If that angle measures x degrees, then we can say that the length of the line is also x, measured in degrees. Notice that using this phenomenon, scaling the sphere to be bigger does not change the length, even though from our perspective it would be a longer arc. It's all relative to the sphere itself.
Given two great circles, they will always intersect, and we shall label this angle of intersection alpha degrees. You might be thinking, hold on, did we just use two separate notions of angles to define different things? Yes, both x and alpha are measured in degrees, but one is an angle, and the other is a length. So back to triangles. With spherical triangles, it turns out that the sum of the three angles is always greater than 180 and less than 540 degrees. Other wacky things are also true about these triangles.
This includes, but is not limited to, the law of cosines, the Pythagorean theorem, the law of sines, all congruency theorems, and, as a bonus, angle-angle as a congruency. Triangles with the same set of angles are usually considered similar, but on a sphere, they are congruent. Lastly, two triangles with the same angle sum have the same area. Most of these properties are familiar to us through normal Euclidean geometry. Spherical geometry certainly abides by different rules than what we are used to, but in the end, it creates a new topic that can be interesting and, dare I say, fun to study.
Yeah, this video really felt like I was watching like VR or something. So yeah, very nice job, PCA. Yeah, and then Carl will be here to announce activity winners. Carl?
Hey everyone. So we had a couple activities that had some awards, and we thought it'd be cool to mention them. Whoops. So for day one, our Estimon day winners, the first place winner was Jarvis. The second place winner was Randomness, and the third place team was Nothing. And then honorary mentions, fourth place was Carrots, fifth place was Candy Orca. You guys were actually really close, which is why we put you on here. And then for day two, first place was Crab, second place was Generic Team Name, and third place was I Don't Know. And another honorary mention, fourth place was Untitled Document, and fifth place was Memory. So for our second activity, we had an integration bee. So Weewa actually won both days. Keishan Jani managed to make it to both day one and day two top three. D'Angelo Brazen made it to second place on day one, and then we had Vishak make it to day two. If you guys want the full scores and everyone who participated, I put the bit.ly links right here, and you can just check to see how everyone else did. And now we're going to go to what we've been waiting for. We are going to announce the winners for the tournament. And our head problem writer, Austin, will take it from here.
I'm muted again. This happens way too often. Can everyone see the screen properly? Just to make sure that this is right. Cool. So if that's the case, hello everyone. I want to paint a little bit of a story before I begin with the awards here. So, this tournament was meant to be held in April, and we're sitting in Eshelman at Berkeley on March, kind of just sitting there, like, yeah, let's run this tournament in April. This is going to be great. And then, that didn't happen. And I think between the time in March and now, we really spent the time to think, like, how can we make this tournament great? And at least from my point of view and from the prom side, we're like, okay, I designed this tournament to be kind of like BMT 2019, but I think we can do better. I really want to make as fun of a tournament experience as possible. And we decided, all right, let's run a guts round. Let's try to make it work this tournament cycle. And I'm really excited with how everything went this year. There were over 1,000 people who went to this tournament this year, and this is by far the largest BMT we've ever held. And I believe that this is the largest college-run math tournament ever in the US. So this is really crazy, and I'm really excited to see where we can go from here. So I'd like to give first some shout outs. So I'm the head problem writer, but I couldn't get this done by myself. It's way too many problems, way too much work. And there's so many people that helped me with this process. So I'd like to first thank all the test organizers. So these were the people who helped edit the tests. They were the ones who basically organized and helped with test solving for all these tests. And I really need to thank all of them. So Hayden, Drew, Anthony, Sylvia, Freya, Alex, and Ankit. You all were so helpful, and this couldn't have been done without you. And it's not just these 7 people who helped with the test organizers. There's so many people who helped us with problem writing and with test solving. And I really just want to give a shout out to all of them. You notice this list is quite long, and there's just so many people who helped us with test solving and problem writing. I really need to give a shout out with all of them. Like, this tournament would not be close to what it was today without these people. So yeah, I want to give a shout out to all of the people here. All right. So if that's the case, I think we can start with all what you all been waiting here for, all of the scores on each of the tests. So first, let's talk about the power round. So this was an unofficial event in the sense that it does not count for the overall team score, but it was its own separate round, and I'm sure you all are excited to see the scores. This year's power round was on mathematical billiards, and it was a lot of Euclidean geometry on different shaped polygons and there's a lot of laws of reflection and things like that. I hope you found this topic fun, and I hope you continue to explore what this topic can bring you. So there were 101 teams who took the power round. The average score was an 80.55 out of 150. The high score was a 148.5 out of 150. And the least solved question was the last question, number 15, which had only 13 full solutions. So let's go on with the power round. So in 10th place, we have Team Green Mustangs with a score of 133.5. Also in 10th place, we have Team SCS Paradox with a score of 133.5. In 9th place, we have Team Tor Epines 1 with a score of 134. In 8th place, we have Team Kick Ben with a score of 140. In 7th place, we have Team BISV Bobcats A with a score of 140.5. In 6th place, we have Team BCA 1 with a score of 141.5. In 4th place, we have a tie for 4th place. We have Team UTSB from the University of Toronto Schools with a score of 144.5. Also in 4th place, we have Team I Don't Know with a score of 144.5. In 3rd place, we have Team Brawlfa Stars with a score of 145.5. In 2nd place, we have Team CNCM Team 1 with a score of 147. And finally, in 1st place, we have Team CCA 1 from Canyon Crest Academy with a score of 148.5. So I want to give a huge shout out to all these teams. Congratulations on doing so well in the power round. All right. Now let's move on to the individual test. So sort of as a reminder, the individual test was a 25 question, 90-minute test. There were 109 students who took this test. The average score was a 10 out of 25. The highest score was a 24 out of 25. And the least solved question was number 23, which had a total of 2 solves. So first, I'd like to show the honorable mentions. These were people who scored in the top 20%. So congratulations to all the honorable mentions. All right. And now I'm going to present the top scorers. So these were all of the people who made it to the tiebreakers for individual. So starting off in 7th place, we have Adi Shah from Team Random Math A with a score of 19. In 6th place, we have Susie Liu from Team SHS with a score of 19. In 5th place, we have Kyle Lei from Team Alpha Star Omega with a score of 19. In 4th place, we have Vishak Shrikant from Team Mathmongers with a score of 20. In 3rd place, we have Nicole Shen from Team YEA Newton with a score of 20. In 2nd place, we have Ishani Agarwal from Team Random Math with a score of 20. And finally, in 1st place, we have Alan Liu from Team Random Math with a score of 24 out of 25. So again, congratulations to all of the top scorers on the individual test. Okay, so now let's talk about the algebra test. So for the next 4 tests, algebra, calculus, discrete, and geometry, as a reminder, these were all 1-hour tests that had 10 questions. So for the algebra test, there were 743 people who took the algebra test, which was by far the largest test that we had today, or this weekend. The average score was a 4.17 out of 10. The high score was a 10 out of 10. And the least solved question was number 10, which had a total of 51 solves. So first, I'd like to go through all the honorable mentions. There's quite a lot of them. So here are the algebra test honorable mentions. Right, and these are all people who scored in the top 20% on the algebra round. Okay, and now let's talk about the algebra test top scorers. So these are all the people who qualified for the tiebreaker for algebra. So we're going to begin in 6th place. So in 6th place, we have Espen Sletnes from Team YEA ADA with a score of 10 out of 10. In 5th place, we have Ankit Bisain from Team CCA1 with a score of a 10. In 4th place, we have Aaron Chen from Team Mission Warriors with a score of 10 out of 10. In 3rd place, we have Wan Zhang from Team Brawlfa Stars with a score of 10 out of 10. In 2nd place, we have Benjamin Fan from Team Beta Stars with a score of 10 out of 10. And finally, in 1st place, we have Andrew Wen from Team Alpha Star Pi with a score of 10 out of 10. So congratulations to all the algebra test top scorers. You all got a perfect score on the algebra test, and you all did very well. Congratulations. All right, let's talk about the calculus test now. So the calculus test had a total of 171 people take the test. The average score was a 5.21 out of 10, and the highest score was a 9. The least solved question on the calculus test was question number 9, which had a total of only 4 solves. So here are the calculus test honorable mentions. These are people who scored in the top 20%. Okay, and let's talk about the top scores. Again, these are the people who qualified for the calculus tiebreaker. So we're going to begin in 8th place. So in 8th place, we have Ethan Zhang from Team The Denominators with a score of 9 out of 10. In 7th place, we have Niraj Ratahali from Team Alpha Star Pi with a score of 9 out of 10. In 6th place, we have Jeshwin Prince from Team Riley with a score of 9. In 5th place, we have Alex Yi from Team Texpacito with a score of 9 out of 10. In 4th place, we have Harry Chen from Team CNCM Team 1 with a score of 9. In 3rd place, we have Siddharth Srinivasan from Team Alpha Star Pi with a score of 9. In 2nd place, we have Kevin Xu from Team Green Mustangs with a score of 9 out of 10. And finally, in 1st place, we have Team Hyunjun Choi from Team Magic with a score of 9. So congratulations to all the calculus test top scorers. Okay, let's talk about the discrete test. So there were 418 students who took the discrete test. The average score was a 4.38 out of 10. The high score was a 10 out of 10. And the least solved question was the last question, number 10, which had a total of 12 solves. So again, let's talk about the honorable mentions. Just like algebra, there's quite a few. These are all the people who scored in the top 20%. Yeah, so again, congratulations to all of the honorable mentions on the discrete test. And now let's talk about the top scorers. And these are the tiebreaker participants for the discrete test. So we'll be starting from 10th place. So in 10th place, we have Gregory sorry, I can't pronounce that last name. I'm sorry. I don't want to mess up that last name. From Team BCA1 with a score of 9. In 9th place, we have Zifan Atticus Wong from Team Prism's Falcons with a score of 9. In 8th place, we have Ben Epstein from Team Lexington High School with a score of 9. In 7th place, we have Alex Yi from Team Texpacito with a score of 9. In 6th place, we have Derek Liu from Team Tor Epines 1 with a score of 9 out of 10. In 5th place, we have David Hu from Team Limbrook Violet with a score of 9 out of 10. In 4th place, we have William Wang from Team Knights with a score of a 9 out of 10. In 3rd place, we have Espen Sletness from Team YEA Ada with a score of 10 out of 10. And in 2nd place, we have Sean Lee from Team YEA Ada with a score of 10 out of 10. And finally, in 1st place, we have Andrew Gu from Team Brawlfa Stars with a score of 10 out of 10. So congratulations to all of the top scorers on the discrete test. Okay. Now we're going to move on to the geometry test. So there were 470 participants who took the geometry test. The average score was a 4.42 out of 10. The highest score was a 9 out of 10. And the least solved question was number 9, which had a total of 12 solves. So let's go through the honorable mentions. So again, there's quite a few. So congratulations again to all of the honorable mentions on the geometry test. And now we're going to go to the top scores. So for geometry round, for the geometry test, we'll be starting from 10th place here. So in 10th place, we have Albert On from Team BISV Bobcats A with a score of a 9 out of 10. In 9th place, we have Mason Fang from Team Wild Kitties 1 with a score of a 9 out of 10. In 8th place, we have Advaith Avad Hanam from Team Random Math with a score of 9 out of 10. In 7th place, we have Kwanlin Andy Chen from Prism's Falcons with a score of 9 out of 10. In 6th place, we have Samuel Wang from the team The Jigglypuff Attack with a score of 9 out of 10. In 5th place, we have Neil Yan from Team YEA Ada with a score of 9 out of 10. In 4th place, we have Eric Shen from Team YEA Ada with a score of 9 out of 10. In 3rd place, we have Derek Dong from Team The Jigglypuff Attack with a score of a 9. In 2nd place, we have Christopher Chiu from Team Alpha Star Sigma with a score of 9 out of 10. And finally, in 1st place, we have Eric Kim from Team The Jigglypuff Attack, also with a 9 out of 10. So again, congratulations to all the geometry test top scorers. Okay, so we've gone through individual, we've gone through all the focus rounds. Let's talk about the team test that we all took today. So the team test, there were 191 teams that took the team test today. The average score was 187.92 out of 417. The highest score was a 347 out of 417. The least solved question today was number 24. That's the last question in set 8 that had a total of exactly 1 solve. I'm going to talk a little bit about the estimation questions. So for number 25, if you recall, that was the question asking you to guess a number between 1 and 50 inclusive. So the average score on that question was a 6.6, and the highest single unique number was a 49. So there was only one person who guessed 49. There were 2 people who guessed 50, unfortunately. And there were quite a lot of submissions that were not in the range 1 and 50. And these were a little bit bizarre. Yeah, you got 0 points, essentially. For number 26, this was the question about twin primes. So the average score was 2.4 out of 25. 47 teams got a score that was not 0. And the correct answer was 183,761. And the best guess was a team that guessed 183,797. So they were only 36 off. And they got 25 points for that guess. Finally, we have in 27, that was the question involving hexadecimal. So the average score on that question was 0.91 out of 25. And only 13 teams got a score that was not 0. The correct answer was 277, and the best guess was 270, which got 22 points. So that's all for the estimation portion of the team round. So let's go through and let's go through the top 10 here. So in 10th place, we have Team Random Math from Random Math with a score of 313. In 9th place, we have Team Knights from West Windsor Plainsboro North School with a score of 315. In 8th place, we have Team Gun A from Gun High School with a score of 318. In 7th place, we have Team Bralfa Stars from Orange County Math Circle with a score of 320. In 6th place, we have Team Saratoga 1 from Saratoga High School with a score of 324. In 5th place, we have Team Limbrook Violet from Limbrook High School with a score of 327. In 4th place, we have Team UTSA from the University of Toronto Schools with a score of 329. In 3rd place, we had Team CCA 1 from Canyon Crest Academy with a score of 340. In 2nd place, we have Team The Jigglypuff Attack from Jung Academy with a score of 341. And finally, in 1st place on the team round, we have Team Tor E Pines 1 from Torrey Pines Math Club with a score of 347. So congratulations to all the team tests So all of the top 10 teams on the team test. I really hope that you enjoyed this year's team test. Okay, I think this is the moment you all been waiting for. Let's talk about the overall rankings. So this is the combination of the team round scores and all the individual round scores. So we're going to start from 10th place. In 10th place, we have Team Lexington High School from Lexington High School. In 9th place, we have Team Saratoga 1 from Saratoga High School. In 8th place, we have Team CCA 1 from Canyon Crest Academy. In 7th place, we have Team Alpha Star Pi from Alpha Star Academy. In 6th place, we have Team Limbrook Violet from Limbrook High School. In 5th place, we have Team Prisms Falcons from Prisms. In 4th place, we have Team Tor E Pines 1 from Tor E Pines Math Club. In 3rd place, we have Team YEA Ada from YEA. All right, so we're down to the last two. Who's it going to be? All right, so in 2nd place, we have Team Bralfa Stars from Orange County Math Circle. And that means in 1st place, we have Team The Jigglypuff Attack from Jung Academy. So there you go. That's your winner for this year's BMT. And congratulations to all of the teams here who made it to the top 10. You all did very well. So that concludes the award ceremony for today. I want to quickly say congratulations to everyone for participating at this tournament. You know, you participated in one of the largest tournaments of all time. And I really hope that you found the problems from today and yesterday extremely fun. And you know, we hope that you enjoy the math that you did. And so thank you all for going to this year's BMT. And we hope to see you all next year, be it online or in person.
Thank you everyone for coming. Yeah, I guess can we stop streaming?